All right, everybody. Hello and welcome to the fourth and final chapter of Module 1. I know that sometimes I spend a lot of time going over things or recounting stories or things like that, and I'm sure by this point you are like, why don't we just get over this and let's get on with the chapter lesson? So I hear you loud and clear, even though you may not have ever said anything. In chapters 1 and 2, we went over sources of information, what can be trusted, what can't. In chapter 3, we really got into the idea of what the types of research that are done, the three types of claims that research makes: frequency claims, association claims or correlations, and finally causal claims or experiments. Well, in chapter 5, we're going to really look into that first one called frequency claims and look at how to construct a really good survey or questionnaire and how to avoid problems that are associated with this. And then we will interrogate the um, validity of frequency claims. So let's go ahead and look at the chapter objectives. Get right into it. So first, we're going to look again as a review from chapter 3 at the difference between a conceptual variable and how we operationalize it. So a little bit of review to remind you of how we did this. I will list 3 ways and talk about 3 ways that psychologists typically operationalize variables. We saw 2 of them in chapter 3, but there is another one that we didn't talk about. I talked about it peripherally, so we'll go over it again. The 3 main ways that psychologists operationalize variables is by asking you questions on a self-report of some sort, observing it, either live or through a recording of some sort, audio or video or both, and physiological measures. I will classify measurement scales as categorical or quantitative. We sort of went over this in the tutorial for the method section when you guys were looking at the Stroop task. Unfortunately, normally the Stroop task is with the classmates in class, but I had to improvise, as you guys saw. We will classify measurement scales, categorical, quantitative, and what ratio and interval scales and ordinal scales, and give you a little bit of practice with that. And then we will talk about the ideas of validity and reliability of a measure. I will also talk about reliability and validity in a frequency claim in terms of the 3 different types of reliability. There is test-retest reliability, there is inter-rater reliability, and internal reliability, and I will explain what each one is and when it is relevant to do each one. At the end of this chapter, your homework for chapter 5 is actually at the very end. At the end is the homework assignment, so I'll go over it as its own tutorial. In addition to those, we will review scatter plots and look at how they can show direction and strength in a relationship. We saw this in chapter 3 briefly as I went over the example of positive and negative correlations. And we will also look at applying the correlation coefficient as a way to describe direction and strength of a relationship. So very close to how you would see it in a correlation, but used a little differently. So even though R is the coefficient or the statistic that is used for correlations, we're also going to see how it's used for reliability and validity. Then we will look at validity. So there are different types of validity. So I'll talk about what identity, face, and content, I will identify face and content validity. And then I will talk about predictive, concurrent, convergent, and discriminant validity, and how validity and reliability are different from one another and how they are the same. Your homework at the end of this chapter is going to revolve around 5 questions, 3 that deal with reliability and 2 that deal with validity itself. And then I will describe how scatter plots are and something we call known groups can be used to not only evaluate reliability, but can also be used to evaluate predictive, concurrent, convergent, and discriminant validity. So let's look at, now that we've gone over what the variables are, how we can measure them. So we're going to look at the conceptual variables as well as their operational definitions in the first portion of this lecture, the 3 common types of measures, and the scales of measurement that we use to look at them. So we're going to start with measuring variables. We're going to go to reliability and then validity and review. Looking at conceptual variables, remember that we used the whiff of rosemary and we used the vocal fry and stuff like that to look at operational variables. So going back to that idea, we can look at things that may have more than one way to operationalize. In the sense, let's look at these variables and their definition, as well as a different type of operational definition. So religiosity, conceptually, of course, you would think that has to do with how religious a person is. But the question that we have as producers of research is, how exactly do we quantify or how do we measure a person's religiosity? So here, one possible operational definition is asking people if they agree with this statement: my religious faith is the most important influence in my life. You can get a yes or no. You can get a scale of 1 to 5, maybe, that people use to rate this statement. Or another possible definition could be asking people how frequently they attend religious services. You can use categories like never, several times a year, monthly, nearly weekly, weekly, even daily. And you can say that a person is more religious or has more religiosity the more often they go to church. Now, obviously, there's the people that only go on Christmas and Easter. Maybe people go once a month, right? So that could be another definition of religiosity and a different way to measure it. Looking at gender, we can ask people to report on a survey if they're male or female. And of course, we know that there are others in between, but looking back historically on this, it's usually one or the other. Or in a phone interview, this is not the recommended way to do things. A researcher can guess the gender through the sound of somebody's voice. That becomes a lot more complicated, and that is highly suggested that we don't do that in this case. Just throwing that out there. Wealth. How do people say wealth, right? Some people measure wealth. The most wealth is, of course, an accumulation of things or goods or money or whatever it is. Some people can consider wealth having a lot of cars, having a house, having a lot of money in the bank, but that's not everybody's definition of wealth. So let's look at here, asking people to report their income on a variety of ranges, less than 20,000, 20 to 50,000, or more than 50,000. And you can have more categories than that if you wanted. But another way of looking at it is just coding the value of a car from one older, lower status vehicle to a 5, maybe a newer, higher status vehicle, good condition, the amount of money that it's worth, right? Things like that. But we can also use, you can say wealth is, having a happy family and a good job and things like that, even if you don't necessarily have a good car or a nice house or make a lot of money. You could be really happy with what you do and still consider yourself wealthy. But it's how the researchers or researcher wants to convey this information. What about working memory span? Working memory span could be administering a digit span test in which people are asked to repeat longer and longer numbers, strings of numbers or words or letters. Or asking people to recall as many words as possible from a verbal list of 30 words. You see the 30 words, try to remember them, and then after a certain amount of time, try to recall as many of those as possible. What about well-being and operationalizing happiness? Happiness, or subjective well-being as it's known sometimes, right? That would be the conceptual definition. Subjective well-being, subjective meaning personal to that person. So what makes me happy may not be the same thing that makes any of you guys happy. One possible way is looking at a ladder of life scale, which has 10 points. So basically, kind of like on a scale of 1 to 10, where are you in life in terms of happiness? Are you up at a 10? Are you down at right halfway at a 5? Or there can be a different measure for this called Diener's five item subjective well-being scale. So it could ask different questions from these 5 items and still get at the same thing. Remember that we can use very specific operational definitions based on the conceptual definition, and there's more than one way or more than one scale a lot of times to do this. So, what other variables can we operationalize? I gave you the example in chapter 3 of aggression. We know that's the act of being aggressive or being mad. Does that mean that you have to physically do something like hurt someone or say some words or things like that? Well, we can check out different ways to operationalize that, as I said. Road rage simulator, blood pressure cuff, right? Things like that. So, looking at subjective well being, we know that that is our conceptual variable. That's our construct. And I use the word construct. We use this a lot in psychology to talk about things that can't be directly measured. So, intelligence, we can indirectly measure with an IQ test, but you can't actually measure intelligence in a concrete way. So it's called a construct. We can measure emotions by seeing how happy, how mad somebody gets, how aggressive, but you can't actually quantify or directly measure emotions. It used to be thought that memory wasn't that way, but researchers found a way to do that. So in psychology, we deal with a lot of constructs. Personality is a construct, right? In order to be able to directly or indirectly measure these things, we need to operationalize it. So, looking at well being or happiness, we can use the 5 item scale, the Diener 5 item scale that I just talked about. We can have somebody observe, or more than one person observe, a conversation of people about things that make them happy, and we can look at and observe the number of smiles that they have during this 5 minute conversation. Or we can use a physiological property. When I talked about aggression, I said that we could go as far as doing a blood pressure test and putting your blood pressure cuff on before they get made aggressive and after, and see what the change looks like in blood pressure. How much does it go up? For this one, for well being, we know that it has to do with the limbic system in the brain, which is the emotional center of the brain. So we can use a brain scan, like an MRI or an fMRI, and we can look and see how much energy is used, how much it increases in energy during this time when somebody is being happy. So these are the 3 types of ways that we can operationalize. We can use the easiest one to use, of course, is the self-report, giving some sort of survey or questionnaire, this 5 item scale, and score it. We can actually directly or indirectly observe. So we can either have somebody watching, maybe it's at a park and you have somebody posing as a person having a picnic, and you're really recording or looking at the number of smiles that the person smiles, the number of times a person smiles during this conversation, or maybe you would video record it and watch it later. Or physiological measures like a brain scan or blood pressure reading. These are the 3 main ways to operationalize. Again, there is a sort of a cautionary tale with the self-report, although it's the easiest and best way to get the information. It is also the most subject to dishonesty because people can answer however they want. They may not actually be truthful. And one of the things that we like to do, as we'll talk about in chapter 6 in the next module, is reminding people that they're anonymous and that we just want them to be truthful. We're not this and these answers are in no way traced back to the person who actually filled them out. So the honesty is the best way for this to progress. But we'll get to that in the next chapter. This one is probably the, observational is probably the most reliable, physiological as well, but it's not as easy to do because you have to have the equipment. Excuse me. Come on. Don't crap out on me now. There we go. So looking at the scales of measurement, again, we went over the main scales of measurement in the Stroop task for the first paper, the method section. And we talked about that there are two main scales that we're going to use in this class for the paper that we write. You can either have it in interval scale or ratio scale, but let's look at what the full scales of measurement are. So we talk about categorical versus quantitative, and in this class, this is actually quantitative research methods, although it's not called that. That's the methods that we're using. Qualitative or categorical is more of a verbal type of thing. And quantitative is when we use numbers and we use statistics to crunch those numbers. So categorical would basically be leveling, just labels or levels or categories. So in a categorical scale of measurement, you're asking for levels. You're asking a person's gender, male, female, or other. Nationality could be anything that you fill in. American, Latinx, things like that. Favorite song could be anything that you write in for that. And that is a categorical variable. The three types of quantitative variable are ordinal, interval, and ratio scales of measurement. Ordinal has to do with the order of something. So it's either in a race, the order in which people finish, as you see here. Ordinal is a quantitative variable in which the numerals represent some sort of rank order. The distance between the numerals may not be equal. The person who wins a race, right, order of finishers in a swimming race, if you've got, Olympic swimmers versus people like me who can swim but aren't very fast, then the amount of time between first place and last place may be a huge number. So you're just looking at the order of things. So the order of finishers in a swimming race, or to rank your favorite movies, top 10 movies in order from 1 to 10 in which you like them, that would be an ordinal scale of measurement. Interval and ratio have to do with equal spacing. So in this case, an interval scale of measurement is a quantitative variable in which the numerals represent equal distances, but you do not have a true zero. So 0 doesn't mean none or is not true 0. In this case, IQ score, right? Because unless you're dead, you don't have an IQ score of 0. Shoe size, children's shoe sizes goes up to 12 and then starts over at 1. So somebody that has a 1 and somebody that has a 12, it may be a children's 12 or it may be an adult's 12. There's no true 0 there. In this case, or 0 is just not part of it. So what we will see is something called Likert scales, which are usually on a scale of 1 to 7. And Likert scales don't have a true 0. So anything that's 1 to 4, 1 to 5, 1 to 7, 1 to 10 is an interval scale of ratio of measurement. Ratio, on the other hand, is simply a quantitative variable in which the numbers represent equal distances, like interval, but there is a true 0. So in this case, 0 means it wasn't done, or 0 means there were none. If you get a score of 0 on an exam, it means you got none of them right, or that you never took it. So, but 0 means something. In interval, we can also use the idea of temperature, because temperature, especially if you live up in the northern area or in Canada, like in the winter, goes below 0. So 0 doesn't mean none. It's not a true 0. 0 is just a number. The temperature goes up to over 100 degrees, and the temperature can go down below 0. So it's not really a true, doesn't really mean 0 or nothing. In ratio, the number of exam questions answered correctly could be 0 if you got none right. The number of seconds to respond to a computer task, 0 means you didn't do it. Or your height. There is a true 0. 0 actually means no height, or no, right? No questions answered correctly. So we'll do a little practice with this just to make sure you get it. Of course, I'll be the one giving the answers here, but hopefully you can follow along, and I'll give you the time to think about it before I blurt out the answer. Here's the practice. Looking at the 4 types of measurement: categorical, ordinal, interval, or ratio. If we were to say eye color would be which one of these? The answer is categorical, because you're looking at categories: green, right? Blue, brown, hazel, which is kind of green, gray, right? That would be categorical. You're just naming a category. What about the rating of well-being on a 5-point scale? That would be like the Diener 5-point scale. And that would be on a scale of 1 to 5, not 0 to 5. So the answer is interval for this one. Reaction time at a computer task has a true 0. So for this one, reaction time would be ratio. What about your parents' marital status? Well, that could be married, divorced, single. It's complicated. So yes, we would look to categorical on that one. Blood alcohol content. Obviously, 0 means that you have no alcohol in your system. So in this case, your blood alcohol content would be a ratio scale of measurement. Degree is usually a good dead giveaway. Degree of pain is felt on a 10-point scale. Well, that would depend. Most people would say it's a scale of 1 to 10, so you'd say interval. If it was a 0 because you had no pain, then maybe it could be ratio, but I would be inclined to say that this one is interval. And no, I'm not trying to use a trick question to get you. I just want you to think, right? Be a good consumer of research before we become producers of research. And finally, seating, order of finishers in a 5K race. I think I skipped that one over. That would obviously be ordinal, as well as the seating order in an auditorium. Again, if it has the word order in it, it's a dead giveaway that it's ordinal. So thanks for going over this practice with me, so I don't feel like I did it all myself, even though technically I did. But, let's keep going. So, reminding you from Chapter 3 of looking at the validities in the types of claims that we make using research. Construct validity in all 3 claims: frequency, association, and causal claims, are asking whether it's frequency claims with 1 measured variable, association claims with 2 measured variables, or causal claims with 1 manipulated and 1 measured variable at least. How well did they measure these variables? So looking at this question of construct validity, the overall question we're trying to answer: did we measure what we intended to measure? And this is really the focus of this chapter. So, of course, statistical validity asks, did we have the right effect size, sample size? Did we use the right statistics? What's the margin of the error? Did we make a type 1 or type 2 error? Also, statistical validity is important in all 3 types of claims. Internal validity only with causal claims, and external validity is most important with frequency claims, but may or may not be important for the other 2. So as we are looking at this, we're going to put our concentration on construct validity to talk about reliability and validity in experiments. So, coming to reliability of measurements, what reliability is asking, not necessarily are the scores accurate or measuring what they're intending to measure, because again, we call that validity. Reliability is asking about consistency. Are the scores consistent? If you're measuring something, are you going to measure it consistently every time that you do it? This is what we mean by reliability. So here is a nice little flow chart, not nearly as complicated as that one from chapter 2, but looking at internal validity, we're asking the questions of is it A and only A that causes B? Statistical validity, are the statistics correct? External validity, to whom, what, or where does it generalize? And here we are, again, putting our emphasis on construct validity. We are asking for reliability and validity. In validity, we are asking if you're measuring what you're intending to measure, and that's the overall idea of construct validity. With reliability, this is where we are right now. The question is, do we get consistent scores every time? We have 3 different types of reliability. Test-retest reliability, which says that people get consistent scores every time they take the test. So if you took an exam and you took the exam again, would the scores be consistent? Or, if I have 3 different classes of Psych 92, I do not. That would be a lot. Would these 3 classes get consistent scores, right? So if you're doing a measurement and you measure the circumference of somebody's head using a tape measure, would you get a consistent score within reason every time that you measured their head? Unless they got some sort of, swelling injury, probably you would. That would be test-retest reliability. Inter-rater reliability is when we have people code things like we're looking at observational data. I gave you the example of looking at and counting the number of smiles somebody has when they're having a conversation to try to measure that degree of happiness. Well, normally, if we were to have people observe either in person live or most likely video recorded, so we can really make sure we get everything there, to make sure that we are as consistent and reliable as possible, researchers will usually have more than one person, at least 2 coders, looking to see if these people are smiling. And so we want to know that the 2 different coders get the same consistency with each other. So if I were to be coding a conversation and someone else with me was also coding the number of smiles, and I came up with that a person had smiled 9 times in a 5-minute conversation, and the other coder, let's say my kiddo, Dr. C, says that they smiled 10 times, it's pretty consistent. I said 9, he said 10, very consistent. But if I'm looking and I say that I'm looking at like just a barely little smirk as a smile, and my son is only looking for the full big grin as a smile, and I say, yeah, it looks like this person smiled 18 times. And, my son comes up to me and says, no, Dada, this person only smiled 6 times. And I said 18 and he said 6. That's really, really bad inter-rater reliability. We want consistency. We want it to be the same number or within, 1 or 2, as opposed to being way off. The third and final type of reliability is internal reliability. And in this case, people give consistent scores on items of a questionnaire. So you want them to be, you want the items in a questionnaire to be reliable towards each other. Whereas if I'm asking things about happiness, as I'll show you coming up, I want all of these things to be about happiness. So how well are the questions and scores on a questionnaire consistent? So test-retest is when you give the test again or measurement again. How reliable is it? Inter-rater is when 2 people are rating the same thing. How close and reliable are they to each other? And internal reliability is looking at questions on a survey or questionnaire and how well do they go together. So the last thing before I get into these types of specific examples is this phrase right here. Reliability is necessary, but is not sufficient for validity. And this is the time where I ask in class, what do you think this means? What does it mean that reliability is necessary for validity, but it's not sufficient? Well, remember what I said validity was, that we are measuring what we are intending to measure. So if we're measuring what we're intending to measure, that also means that it has to be reliable, meaning that we have to get consistent scores or consistent answers or whatever, consistent measurements every time. But just to say that we get consistent measures is not enough to say that we're actually measuring what we're intending to. All it's saying is our measurements are reliable, right? So reliability is necessary. In order for us to be measuring what we're intending to measure, it has to be reliable, but we may be measuring something that isn't hitting the mark. So I'll get into that more as we go, because you may be very confused at this point. I apologize if you are. So the three types of reliability, again, test, retest, inter-rater reliability, and internal. Test, retest is if you give that test, questionnaire, measurement, whatever it is, over and over again, will people get consistent scores? Inter-rater, will more than one coder give consistent measurements or codes? And internal is looking at the items on a questionnaire or survey, and are they related to each other? Will we get consistent answers for consistent questions? We will show, I will show, using a scatter plot, how to evaluate if there's good reliability using the scatter plot itself and the slope of a line, or the actual R value that goes with that slope, right? As we sort of showed in chapter 3 with association claims or correlations. And then finally, how can we tell when reading journal articles that they used measures of reliability in their assessments? I will show you some examples, or at least one example. So again, the three types of reliability are test, retest reliability, inter-rater reliability, and internal reliability. When is each kind of reliability necessary? And this may be a slide you come back to when you're going over the homework assignment of chapter 5 and asking the question of what type of reliability we would use in a certain situation. Well, if you are giving a pre-test, post-test type of design where you're giving somebody a measurement and then you're going to measure them again for some reason, that would be test, retest. So think about an example. I just had it in my head and I lost it for a second, but it'll come right back to me. I remember now. I gave you the example in the last chapter of a medication that can be used to reduce depression. So in order to know if there was a change, you need to give the depression test the first time, and then you need to give the depression test again. Now, of course, you're not expecting complete reliability when you do it, because you're hoping that the depression score goes down. But let's think about the people in the placebo case. You're hoping that with the questions that you use, that when you test them again, that their answers would be consistent when you take it. Or, again, if you're doing something like measuring the circumference of somebody's head and you measure one at 62 inches, the next time you measure it, it should be really close to that 62 inches. If you measure their head as 62 inches around or across or whatever, and then the next time you get something like 54 inches, then you know you don't have test, retest reliability. Inter-rater reliability is always looking at two people's observations or coding, and internal reliability would be items on a questionnaire. So when you're looking to make sure that your questionnaire is getting at the right thing, we want to make sure your questions are consistent, right? Why is reliability an empirical question? Remember, we talked about empirical as wanting to get evidence on a lot of things or a lot of people and not just on one thing. So why would reliability be an empirical question? Well, the answer for that is because you want to know that there is consistency. And to know if there's consistency, you need a lot of information and a lot of people and a lot of data to figure that out if it's actually consistent. And again, what does reliability tell us? It doesn't tell us if we're measuring what we're intending to measure, but it tells us that our measurements, as we see them, are consistent with one another, that they're very close to where they should be every time we do it, within reason, of course. So we can use a scatter plot to actually evaluate consistency and reliability. So again, I brought up the idea of measuring head circumference because obviously I knew that this is the example given in the slides in the book. So looking at these measurements, we see measurement 1 and measurement 2. This doesn't tell us how far apart they were measured, but you would imagine not too far apart. So the first person, and this could be the same person measuring twice, or it could be two different people measuring first and then second. But it's the same person who was measured. So what I mean is, here's Taylor. Taylor's first measurement of the circumference of his head was 50 inches, or centimeters, sorry, 50 centimeters. 50 inches would be a lot. 50 centimeters was the first one. So here's Taylor right here. Taylor's first one was 50. So here's 50. And the second measurement for Taylor over here was 52. So pretty close, within 2 centimeters of Taylor, of herself. Kendra was measured first at 61 centimeters. So here's Kendra at 61 on this side, and then at 59 on the other side. So again, within 2 centimeters. Seems pretty consistent, pretty reliable. Mateo, who's even closer to this line of best fit, was at 65 in the first measurement, 64 in the second measurement, within 1 centimeter. Very good. Kurt, on the other hand, the first measurement was a 75. The second measurement was an 80. Kurt is not very far off from this line of best fit, right? If Taylor was 50-50, Taylor would be here. If Kendra was 61-61, would be here. If Mateo was 65-65, would be here on this line, right? This line of best fit. So according to this, the closer you are to that line, the more reliable it is. And even Kurt, who was 5 centimeters off, was still pretty close. If anything, we would say, Kurt, maybe we'd give you a third measurement just to be safe. Everybody else was within 1 or 2 centimeters. So even with Kurt, we would say it still seems pretty reliable in this case. So this is how we use a scatter plot to determine reliability. Looking here so that would be, just to reiterate, this would be test-retest reliability. You're measuring once and then measuring the same thing again. For inter-rater reliability, we're now looking at more than one person's assessment. So again, I used number of smiles in my example of it. Now we're just looking at how close together two people's ratings are. Again, it could be something like smiles. It could be anything you want it to be. But looking at the scatter plot, we see here that on the left is observer Matt's ratings, and here's observer Mark's ratings. So let's just go ahead and use number of smiles again. In this case here, Jackie was 3 smiles according to Matt and 2 smiles according to Mark. Very close. There's a lot of points of people that are pretty close to the line. Here's Jay. Jay is basically on the line. Here is 9 and 9. They were actually basically the same. Matt and Mark about Jay, about Jackie, and everybody else on this plot is really close to this line. The line is sloping upward. The more upward it slopes, right, the more reliability we have. As opposed to Peter compared with Mark. Here we see the line of best fit is a lot flatter, closer to 0. And let's look at some of these lines. So we have a couple that are right on. This person, 3 and 4. This person looks like, 7 and 7, which is good. But looking at Jay seems to be pretty close. Jay got a 6, according to Peter, smiled 6 times. According to Jay, smiled 9 times. Not the greatest, but not far off. But look at Jackie over here. this is really not good, and some of these up here are really not good. When we look at it, according to Mark, um, Jackie smiled 2 times, but according to Peter, Jackie smiled 7 times. So that is a lot far off, and so this shows a much less inter-rater reliability. If the dots are a lot closer to this line of best fit, you would say that this has much better and inter-rater reliability. So, in addition to actually seeing the line of best fit, we can use the scatter plots by looking at what we would either see and notice would be the line of best fit. Here we can actually see where it would come in because it looks like a nice straight line. Whereas here, we see it's a little less likely, or maybe it's harder to tell. So we can use the correlation coefficient. So one of the ways that we determine reliability is we say that a good rule of thumb is about 0.8 or 0.80. Remember, it goes from 0 to 1. So anything in the area of 80 to 1, right, 0.80 to 1.0 is going to be reliable. A 1 would be that they get the exact same score every time. So, of course, that would be the most reliable because it's exactly the same. So, looking at the correlation coefficient, here we see it's kind of spread out, and there is an upward sloping trend, but we're not sure exactly what that line would look like. We go to the R value, and here's the R of 0.56, which is sort of a moderate level of correlation. But again, our rule of thumb is around 0.8. So 0.56, I would say that this is not very good reliability. Here, we can see everything is close to a line of best fit, and just to show that, here is the R value of 0.93. That's definitely higher than 0.8. So we would say that this one has really good reliability. Down here, we can still see maybe a line of best fit, but there are a lot of dots that wouldn't be close to that specific line. Well, let's look. Remember, it doesn't matter if it's negative or positive in correlations. However, if you're getting consistency, it's only going to be an upward slope. So whereas it doesn't matter in an association claim if something is positive or negative, that just shows the relationship of the variables, whether they're both going up or down, or whether in a negative one is going up and one is going down. We absolutely do not want a negative correlation in reliability. 0.8 and above means positive 0.8 and above. So anything negative, we're not even looking at. No reliability there. And this one, obviously, it's all over the map. Your line of best fit is probably going to be a straight, flat line, horizontal line. Here, your reliability is 0.01. It's basically 0. So that is not good. That just means that the consistency is there is none. So that's how we use the correlation coefficient. So we've seen examples of test-retest reliability in measuring head circumference. We've seen the inter-rater reliability back here of 2 observers. Mark and Matt seem to be really reliable and on a good place, whereas Peter and Mark, not so much. So that's not good inter-rater reliability. The last one is called internal reliability, and this is the only type of reliability where we use a measurement called Cronbach's alpha. And Cronbach's alpha just basically takes all of the it's just a sort of complex set of measurements of all of the items correlated together on a questionnaire and spits out a value. So with internal reliability, you're not going to use a scatter plot. You would use this sort of index, statistical index, and you would be able to see this in a sometimes it's called coefficient alpha, sometimes it's called again Cronbach's alpha. And you would see that in publications in a table like this. So here, when we're reading about it in journal articles, sometimes you would see, here's your test-retest reliability, here's the numbers. Here is your coefficient or your internal reliability. Inter-rater can also be done, or inter-rater can be rated. You may not necessarily see inter-rater reliability written in the article, but you would have to assume for observations that it was there if it was, publishable. So, looking at this, these are all these different scales of, since we used happiness as a measurement, these are all different scales that rate subjective well-being or happiness. So if you're looking to see which one, so here it is, estimates for internal consistency or internal reliability and the amount of time in between tests. So you'll see why we have test retest as well, because they gave this happiness test at more than 1 point. So here we have internal reliability, meaning the questions are consistent with one another on these scales. And then we have test retest reliability because these tests were given more than once, right? Because this is a self-report, we don't need inter-rater reliability here in this example because we don't have other people doing this. This is just looking at the questions themselves for internal reliability and looking at the time in between tests for test retest reliability. So looking at this example, we see Alfonso and Allison from 1992, and looking at the consistency of the questions, we see a Cronbach's alpha value of 0.89, which tells us, again, it's above 0.8, that this is a really strong internal reliability. The questions are all having to do with satisfaction with life or happiness, and this is a good score. Test retest reliability, again, it's a 0.83, so it's above 0.80. So this seems pretty good. They give it to a person the first time and then 2 weeks later. That's what temporal or time interval means. So after 2 weeks, we get a good test retest and a good Cronbach's alpha. Pavot et al. Did a satisfaction or happiness scale in 1991. We got a Cronbach coefficient alpha of 0.85, still pretty good. Not as good as the Alfonso analysis, but still pretty good. And we still have a consistent test retest reliability when it was taken a month apart. So that's really nice. 2 weeks, okay. 1 month and still getting a nice 0.84, great. Here is Blaze et al. Blaze and others in 1989. Their coefficient runs between 0.79 and 0.84. So we're on the border, but we're still, sorry about that. We're still in a good range for it being reliable. The questions may be a little more scattered or may have a little bit more not in common with each other. And then there's something here that's a little suspect. The test retest reliability is down at 0.64. One thing you have to take into account is maybe why it might be so much lower. Here, within 2 to 4 weeks, we have a good consistent test retest reliability of 0.83 and 0.84, but this one is 2 months later. Still, 0.64 would raise a few questions. Is it really that consistent then? Because if we go to Diener, remember Diener had the 5-point scale. This is Diener and colleagues have a coefficient alpha of 0.87, so the questions are really good, really consistent in measuring what they're trying to do. Whoa. But after 2 months, their test retest reliability is 0.82. So I would definitely think that these numbers for Diener look better than Blaze. And so if you're going to use one of these scales, right, one of these questionnaires, Diener, if you're doing it 2 months later, seems like a better option than Blaze. Yardley and Rice, we have 0.80, 0.86. Maybe there's 2 questionnaires looking at them. You get a 0.50, but that's 2.5 months later. So still not sure how great that would be to use. And then we have one that's Magnus, Diener, Fujita, and Pavot, which has a coefficient of 0.87, really nice, and a test retest of 0.54. But if you look at that, right, that seems really low and brings up red flags. But now you look at the interval, 4 years later. Think about the difference in 4 years. 4 years could be going from starting college to being done with college. And that's very different in a happiness scale. Could be 4 years of marriage or strife. Could be 4 years of a presidency that I'm really hoping to be over with Trump. and stuff, so that could change people's happiness levels over 4 years. So this whole 0.54 test retest, when you take into account that it's a 4 year interval between tests, may not be so bad, because it can be a huge difference in your consistency. It could be the difference between having and not having depression, and taking a test of happiness, right? And things like that. Or living with your folks to being independent, and things like that. So try, as a good consumer of research, to take everything into account. I would say that the top two, really good. Third one, suspect. Fourth one, really good. Fifth one, not sure. And even though this has a low test retest reliability, take into account that it's 4 years later, not a few weeks or a couple months. Okay, so again, internal reliability is not to be confused with internal validity. Internal validity is saying that A and only A causes B, and there's no alternative explanations. With internal reliability, we're saying that all the questions in a questionnaire or survey should be consistent if they're measuring the same thing. So it's the extent to which multiple measures or items are all answered the same by the same set of people. And again, all of these items, let's say that this is the the Diener 5 item, whatever, subjective well-being or happiness. The Cronbach's alpha is a calculation of the average of all possible item total correlations, or how much they correlate with each other in consistency. Something you will never have to calculate, but you do need to know specifically that Cronbach's alpha is only for internal reliability. It is not for test retest, and it is not for inter-rater reliability. So looking at these items here, we can see which ones are really consistent with one another and which ones maybe don't have anything to do with one another. In most ways, my life is close to my ideal. Is that something to look at life satisfaction or happiness? Yes. The conditions of my life are excellent. These two are very related to each other. If your life is close to your ideal, then the conditions of your life are most likely excellent, and there is a high degree that you would answer very similar to both of these. At number 5, if I could live my life over, I would change almost nothing. 1, 2, and 5 seem very close together. If you score high on 1 and 2, you're most likely going to score consistently high on number 5. But what about 3 and 4? Is there good internal reliability in terms of questions 3 or 4? I am fond of polka dots. Well, I don't think polka dots necessarily has anything to do with happiness, unless polka dots are specifically part of what makes you happy. For me, polka dots are, okay, but I wouldn't consider fondness of polka dots having anything to do with my life satisfaction. Whether or not you're a good swimmer, unless swimming is part of your happiness, right? Then being a good swimmer doesn't necessarily have anything to do with happiness. People may be very happy in life and they never learn to swim, right? So 3 and 4 would not have good internal reliability, but 1, 2, and 5 would. So hopefully this really hammers the point home. So that's reliability. When we say that it is necessary but not sufficient, it is because in reliability, you can be very consistent with your measurements, test retest, very consistent with the people who are measuring observations, inter-rater, and even have questions on your survey be very consistent with one another. But are you measuring what you're intending to measure? Here in this, if you're measuring life satisfaction, but your variable is something else, right? Like swimming or polka dots, then you're consistent with your questions, but you're not actually measuring what you're intending to measure. So when we say that reliability is necessary for validity, it's in order to be measuring what you're intending to measure, you also have to be consistent with your measurements. But your consistency itself does not mean it's valid. Hopefully that makes sense. I do have another graphic towards the end of this that will make it a little more clear. So validity, again, is asking the question, does it measure what it's supposed to measure or what we are intending to measure? When we give something an operational definition, are we actually measuring it in the way that we're intending to measure it. So, looking at measurements, does it measure what it's supposed to measure? So we'll talk about the measurement validity of constructs, right? When we are directly measuring something, it is very easy to do that. When you're measuring weight, as you see the woman on the scale, you get a direct number based on your weight that the scale gives you. When we are measuring constructs, like psychological terms like emotion, intelligence, right? Things like happiness, on this case, which is one of the emotion things, subjective well-being, it's harder to know how consistent it is and that we're measuring exactly what we're intending to measure. So there are different facets of validity that tell us how well we're measuring what we're intending to. Face validity says, does it look like we have everything that we need? When you're measuring happiness, how do you define happiness conceptually? How did you operationally define happiness? And just by looking at it, did we capture what we intended to capture? Content validity says, did we get all the measures that we wanted to? So in happiness, are we looking at smiles? Are we looking at brain scans? Are we looking at, right? What parts of happiness are we trying to measure with this? And did we capture all of them? Does it look like we got everything we wanted to? Then we have criterion validity. And criterion validity asks the question, are there key behaviors that would show that it correlates with them, that it's consistent? So would you see a high degree of this in this measure? So happiness, right, could be the number of smiles. And smiling a lot could be a key indication of happiness, right? That part of the brain lighting up could be a key indication of happiness. If we're looking at religiosity, it doesn't have to be a key behavior of going to church. It could be how much you pray every day, or it could be, how much you invoke your faith in God or something like that for religiosity. It doesn't necessarily have to, right? So key behaviors like going to church or like praying or saying grace or whatever it is, right? Celebrating Christian Catholic holidays, whatever it is, or religious holidays. It's not just, I don't want to limit it. And then we have convergent and discriminant validity. Convergent means that things that go together should be consistent, and things that don't go together shouldn't be as consistent. So in convergent validity, you may have, if we go back really quickly to these different measures of happiness, all of these things are trying to measure life satisfaction or happiness. So 2 of these tests should be very highly correlated with one another since they're measuring the same thing. Whereas happiness and swimming may not be. So for discriminant validity, a test of happiness should not correlate as highly with a test about your feelings of swimming, right? Things that go together should be highly correlated. Things that don't go together as much should not be as highly correlated. So the pattern makes sense. And then we'll finally look at the relationship specifically between reliability and validity in that graphic that I promised you. So here, now we're down here. Looking at validity, we have 2 subjective ways, personal ways to assess validity. Face validity, it looks like what you want to measure. It looks like you did a good job of coming up with an operational definition for it. And content validity means that it contains all the parts of your theory, or that your theory says it should contain. So it's a complete definition. Then down here we have criterion validity. These are the 3 empirical ways to assess it. That your measure's correlated with some sort of relevant behavior or outcome. That your measure is more strongly associated with measures of similar things, like, again, 2 depression tests or 2 happiness tests should correlate very highly because they're both assessing the same thing. And it should also be less strongly associated with dissimilar constructs. And I'll get to another version of that. I did give you the example of a happiness test and a swimming type of test, or feelings on swimming should not correlate as highly as 2 happiness tests, right? So that's what we mean by convergent and discriminant validity. Convergent means that they should correlate really highly if they're measuring the same sort of thing, and discriminant is if they don't, they should not correlate as highly. And you'll be practicing this in the homework. So face validity asks the question, does it look like a good measure? A lot of times you can ask an expert and they would give you the best advice on that. Yes, it looks like you have everything that you wanted to measure here. Again, content validity, does it include all the important components of your construct? If there's more than one part to happiness, did you include them all? Sometimes it could just be a self-report. Sometimes you say, we really want to know. So maybe you'll give a self-report and you'll do a brain scan and you'll have somebody look at the number of smiles. That way it includes all of those facets. That means it has good content validity. We can look at criterion validity in how well it correlates to a key behavior. So looking at this example, and using this, you can look back on this when you're trying to think of it for the homework. But looking at sales, which is a job that requires a lot of outgoing personality, being able to read a person, see if you're losing them, see if you're catching them, that the amount of money you make should be predicted pretty well by your ability on a sales ability test. If you score pretty high in your sales ability test, which shows you have good sales prowess, right, sales personality and ability, then that should relate to how much money you make from sales, right? Whereas your IQ score is probably not a very good predictor of how much you'll make in sales, because it's more about your personality and your attention to detail than it is about your IQ. You can say that IQ is more about book smarts, and sales might actually be a little more about street smarts and being able to read people. There can be plenty of people that have lower IQ but be really savvy in sales, and there can be a lot of people that have a high IQ. And one of the criticisms that people give to PhD students is that you're thinking critically and practically, so you're not using common sense. I don't think I fall into that category, but I also know a lot of colleagues of mine that kind of do fit into that category, where you have a really high IQ, but you're either not very outgoing, or you're lacking in certain things like common sense, and so you may not be very predictive of how you do in a sales job. So a good criterion validity would be your sales ability test score to predict or correlate with how much you make in sales in a given year. But your IQ score will not be a good predictor, and therefore not have good criterion validity. Again, we can see there are a lot of points away from the line of best fit. Finally, looking at criterion validity may be something that we call known groups. There may be things that you're studying where you already know things. If we're looking at depression scores, the BDI it's known as the Beck Depression Inventory, and Beck was the one who came up with this scale. The higher you score on this scale, the more depressed a person you are. So you can look at criterion validity for depression using a BDI score, and you can see a psychiatrist's judgment of not depressed or depressed, or you can look at it by severity. So here you see the rating is lower for not depressed, it's a little bit higher for mild, higher yet for moderate, and even higher for severe depression. So the higher score correlates with the more depression. So knowing this, you can look at it this way as a key behavior. Is this Beck Depression Inventory valid? Does it have criterion validity? Well, look at the people who are more depressed or less depressed and look at their scores. And if it's consistent, right, then we have good criterion validity. Of course, it's easier to use the scatter plots. This is just another thing, another way we can do that. Looking at known groups evidence, we may not even need a chart at all. We can just look at some of these scores and understand. So this is, again, subjective well-being or happiness scores for different groups. And again, what we know from these groups already, right, using empirical evidence from many things, is we can predict which ones would be higher and which ones would be lower. American college students tend to be pretty happy. Um, in this case, we see a mean score of 23.7, pretty high. French Canadian college students also pretty happy. In Russia, you're not going to see people as happy, most likely, um, based on things. So you see a lower score based on this study reference, 18.9. Looking down here, older adults seem to be, in retirement, maybe pretty happy. Um, Score of 24. Printing trade workers also pretty high. VA hospital inpatients, a lot of people who served in the war, are vets. A lot of problems. You would expect, based on what you know, that this would not correlate very high with happiness, and that's exactly what we find. As opposed to these 23s and 24s, we have a score of 11.8. Male prison inmates, also a lower score. One that was really confusing for me is women that are abused, although, again, if you're using self report, a lot of times abused women will claim that they're happier than they are. And if we're relying on a self report score, that's why their scores may be higher here. Not as high as retirees um, or college students, but that's where you would still see some sort of, validity there. So based on known groups, we don't even need necessarily a scatter plot or a graph to know this. But we're not going to focus too much more on criterion. Instead, we're going to look at convergent and discriminant validity. In convergent validity, two things that should go together should correlate really highly. So again, if you're looking at depression, we have the BDI down here on the x-axis. We have the CESD, which is another test that measures depression. And even though they may have slightly different things, slightly different questions asked on each one, they're both measuring depression, so they should correlate really highly with each other, and that's exactly what we see. So two scores of two different depression tests should be show convergent validity for to each other. They should be highly related to each other because they're both measuring the same thing, and that tells you that you're measuring what you're intending to measure. Whereas a BDI score, which is depression, and a physical health score should not be as close together, and they should not correlate as highly. A lot of times you may think of mental health and physical health going together. I even pointed out in a previous lecture that evidence-based treatment from chapter 1, that aerobic exercise actually helps relieve depression, but people that are not physically healthy can be depressed, and it could be because of some illness, physical illness that causes depression. People who are athletes can be depressed. We've seen this a number of times. So a physical health score should not correlate nearly as highly with a depression score as another depression test would. So two depression tests should correlate highly. This is what we call convergent validity. And a physical health versus a mental health test or depression test should not correlate as highly. This shows discriminant validity. This is what we want to see. Two things that should go together do go together. Two things that shouldn't go together don't go together as much. This tells you that our measurements are valid. So, the last thing we're going to talk about is the relationship between reliability and validity. And then when I get to the actual homework part, I'm just going to do a separate tutorial, so it won't be part of this lesson, although I will give you a glimpse. Actually, that's not true. I changed my mind because I realized there's no prompt for the homework. It is actually just part of this presentation and part of the slides, so it'll be on that. Sorry about that in mid-sentence. The validity of a measure, again, is not the same as the reliability, right? Reliability is all about consistency. Validity is asking, did we actually measure what we intended to measure? So a measure can be less valid than it is reliable, but it can never be more valid than it is reliable. I hope that makes sense. And if not, this little graphic or chart will hopefully give you more clarity on that. So again, the phrase that we're using here is that reliability is necessary because it has to be consistent, but it is not sufficient. It has to be valid and reliable. It can't just be reliable. So reliability is necessary, but it is not sufficient for validity. And here's what I mean by that. Can a measure be reliable but not valid? Yes. Shoe size as an intelligence test. You can have a bunch of shoe sizes that are very consistently measured with one another, but has nothing to do with intelligence. There used to be a saying, right? Big feet, big brain. But there are plenty of people that are short that have very good intelligence, right? So the shoe sizes together can be reliable, but shoe size is not a valid measure of intelligence. What about the number of children a person has or a family has as a measure of how interested you are in children? You might think that the more you love children, the more children you'll have, right? But there are also plenty of people. You can measure it reliably. Your measure of how many children somebody has is a reliable measure, but is it really correlated with their interest? I know plenty of people that wanted huge families and they weren't able to, and they maybe only have one child or two, even though they wanted five or more. So they're really interested in children, but maybe they can't have them. Or I also known people that have a large family that didn't necessarily mean to do that. And although they love their children, right, that doesn't mean that they were interested in having double-digit children, right? So that is consistent measurement, but not, reliable, but not valid, as opposed to their interest in having children. And that's all I'll say about that. So a measure can be reliable but not valid, but can a measure be valid and not be reliable? Well, if we go by that term, that reliability is necessary but not sufficient for validity, then the answer is no. If you are valid, then you are consistent. Then you're reliable. If you are not reliable, you cannot be valid. You cannot have a valid measurement if it's not consistent, right? You can be consistent but not valid. You cannot be valid without being consistent. So if we use this target, right, being valid is the bullseye. Being reliable just means that the measures are measured together. So here, this is what we want in our questionnaires. This is what we want in our construct validity. We want to be both reliable and valid. We need to be consistent, and we want to be measuring what we're intending to measure, which is the bullseye. If we are reliable but not valid, here we are way up in the corner. Everything's consistent here, like this one, shoe size. All the measurements are consistent, but we're not near the bullseye on measuring what we're intending to measure. And then finally, if we're not reliable and we're not valid, then we're just all over the map. But there's no way that you can be consistent, you can be valid and not be consistent, right? So when I say that reliability is reliability is necessary but not sufficient. See, now I'm getting my own phrases mixed up. When I say reliability is necessary but not sufficient, it means that in order to be valid, it has to be reliable, but it can be reliable here without being valid. Thanks, guys. And now on to, if I can get to it, if it lets me, on to our homework. So here's the tutorial that we will go over on a separate sheet of paper, just on a document, or if you really wanted to, you could write it down on a piece of paper and take a picture of it and upload it that way. Because here I give you the option of either drawing a scatter plot on your own or just describing a result. which is perfectly fine. So I'll go over the first one with you. So really, you guys will only have to do 4 of the 5. But I would like you to try your best. And if you don't get the answer right on this, as long as you try and answer the questions to the best of your ability, I will give you the full 5 points for this. Normally, we do this in class, or we go over the answers um, after after you come back and you do the rest for homework. The next time we meet, we would do that. So because we don't have that option, I'm still going to go over the answers for you guys. I can put up another sheet, or I can do it during office hours or something like that. But I just want to make sure you're trying your best. And if you have questions on it, please feel free to email me or see me in office hours. You'll have a little bit of time to do this. So for the first 3 questions on this slide, we're looking at reliability. Remember that there are 3 different types of reliability. So for each question, the first thing I want you to do is answer what kind of reliability would you need. So which of the 3 do you think works for this case? And then either draw a scatter plot, or again, if you're just writing this on a Word document or something like that, Google Doc, then describe a result that would indicate this measure has good reliability versus one that shows poor reliability. Of course, the scatter plot that is giving me a line of best fit, that's an upward sloping line, and having dots really close to that line or on the line will show good reliability, whereas having ones that are not close to the line will show poor reliability. So if you want to draw those and that's easier for you, great. Or you could just describe it this way when you're writing it. So let's do number 1. I'll do it basically for you, and then I'll have you guys do 2 and 3, and then we'll look at the next version, which is validity. So in reliability, this says that researchers place an unobtrusive video, meaning that it's not where somebody can see it. Recording devices in the living room of 20 children. Of course, you would assume they got parental permission. We don't want to do something unethical. So with the proper permissions, they placed recording devices, video recorders, in the living rooms of 20 different children. Later, these sessions are recorded, and coders, this should be a giveaway, view tapes of the living areas and code how many minutes each child spends playing video games in that given time. So basically, the coders independently would have the video, they would have a stopwatch, and they would count up how long the children spend playing video games. So would this be test-retest reliability? Would this be inter-rater reliability? Or would this be internal reliability? Well, if we were to think about this, test-retest is looking at doing something repeated times, repeated measures, or repeated test, and seeing if the answers were consistent with one another that they give. In this case, they're only seeing things once. It is not test-retest. In internal reliability, that's one where we look at surveys and questionnaires, and here we don't see that. But inter-rater reliability has to do with more than one rater or coder to see if they're consistent measurements. In this case, it would be inter-rater reliability, because we would have 2 different coders with stopwatches, and we would hope that they would consistently be counting numbers that were close. So you could draw a scatter plot looking at, number of minutes, or you could simply say, Matt and Mark found, with children that consistently, if one was 5 minutes and the other said, 4 minutes and 50 seconds or something like that, that they were very close to each other in all of the children that they coded. Poor reliability would be something like, Mark and, Peter? And, one person says that this child played video games for 10 minutes, and the other one said they only played video games for 3 minutes. That would show poor reliability here. So inter-rater reliability, and you could either draw that scatter plot, or you could just describe those things very simply. You don't have to go into much detail. I get it from a very simple explanation, right? Trying to use that parsimony that we talked about in chapter 1. So for number 2, a clinical psychologist or clinical psychologists together have developed a 7-item self-report measure to quickly identify people who are at risk for panic disorder. So think about what type of reliability this would be and how you would show it has good reliability or how you would show that it has poor reliability. I want an example of each, like I gave you for number 1. And finally, for number 3, a restaurant owner uses a response card with 4 items in order to evaluate how satisfied customers are with. Number 1 is the food, how it's rated, the service, how it's rated, the ambiance or background theme of the restaurant, if there's music playing maybe, and the overall experience together. What on this response card with these items would this be? What type of reliability would need to be evaluated? Is it test retest? Is it inter-rater? Is it internal reliability? And how would you show that there's good reliability, and how would you show that there is poor reliability in this case? So those are the first 3. I did the first one basically for you. You just have to copy it down. And then the last 2 questions, which I really should put 4 and 5, but it's 1 and 2 for validity. So for the homework, again, 1, 2, 3, 4, 5 is perfectly fine. It says, how might you show that this has criterion validity? Remember that criterion validity means that it is associated or correlates highly with a key behavior. So if I were to mess with you guys and go back, let's do this. Go back to, trying to get back to it if it'll let me, but it's being stubborn. So maybe I can do it this way. Go back to key behaviors. We see that sales correlates highly with sales ability test scores and does not correlate as highly with IQ score. So now let's go back to the last one, and I will make it bigger. And you can see that clinical, I'm going to use the same example from question number 2 for question number 4, but this one is not reliability, this is validity. This says clinical psychologists have developed a 7-item self-report measure to quickly identify people who are at risk for panic disorder. So think about what kind of behaviors a person has that would correlate really highly with people who are at risk for panic disorder. Maybe symptoms, maybe ways they behave, maybe things like that. Then it says, how might you show this measure has convergent and discriminant validity? Remember that convergent validity is things that correlate highly. So the last time the example I gave was from this lecture was 2 types of depression tests would correlate highly with each other. So if this is a report for panic disorder, what else would that correlate highly with that you could give them? And discriminant validity would be what shouldn't correlate as highly. So discriminant validity, we had 1 depression test and 1 physical health test that should not correlate as highly as 2 depression tests. Here you have a test for panic disorder, some sort of anxiety type disorder. What would correlate highly with it to show convergent validity? Again, you could just write that down. You don't have to show it on a plot or anything like that. And what wouldn't correlate as highly with it that shows discriminant validity? Finally, we'll go again with a restaurant owner who uses a response card, but in this case, he uses or she uses a response card to evaluate how satisfied customers are just with the food. It only contains 1 item that says, please rate the quality of this food on a scale from 1, very dissatisfied, to 4, very satisfied. What criterion validity, what key behavior would be consistent with their score on this card? And what things would show convergent validity? What would this rate correlate very highly with? And what would show discriminant validity on here? What would this not, the quality of the food, what would it not rate very highly with in your restaurant experience? So those are the 5, I gave you number 1, basically did it for you. All you have to do is write it down. And then for the other 4, I would like to see your own answers for this. So 1, 2, and 3 are on reliability. You can tell I'm tired, right? And the last 2 are on validity. Thank you very much for sticking around for the tutorial and the homework. And this was Chapter 5. You now have all the information from the first 4 chapters for the first exam. And as always, I'll see you in Module 2, and I will talk to you soon.